Today I want us to discuss about the orthogonal persistence, and when you see this, we can say top up with 100, and when we call that function and we query, you see it's 1 or 3, it's 2 or 3. Then we can add another 100, and we see here is 3 or 3, so it is ending. And the reason here is why we want to use this feature called the orthogonal persistence is because when we just change anything, like let me comment this line and then Control S and then run dfx deploy, give it some few minutes. Yeah, let's now see what is happening here. So let me open this. And when you query, you find it has erased everything to 103. So this problem is what we are going to solve. And this is going to be solved by making this function, this one, this variable that is storing this current value table. So when we make this table, it will not refresh everything to the beginning. So we do that by adding the keyword table, and we have made this. We have made this variable table now, so we can Control S to save the changes, and we can also run dfx to deploy. And now when we do like this and we query this balance is 103, let's add another 100. And now when you query, the balance is 203. Now if we go back and we change anything here and we Control S, then we run we run dfx deploy, then this should not give us the 103 as the current value, because now this variable has become stable and is not going to change or to reset the whatever is stored in it to previous version or to previous value. So when we come here and we now open it again and you query the same question, we find is 103. Then we add 100 and we call this function, and we can query, that is 103, and now that is coming to that every time you want to do that. So now we can control this to comment this line, and then we control S to save the changes. And even if now we do deploy dfx deploy again, we are going to find our same 203, because this one is now not going to be affected by anything. Okay, this is not going to be affected by anything. So let's now come here and query. You see, it is persistent, it's 2 or 3. Even if you change anything else here, like the bank, this one, you do like this and you run, you control S and dfx, and you run this function. Now the same thing is going to be done when you query. It's 2 or 3. And when you want another one, it is gonna be persistence, and now is 3 or 3, and you can withdraw 100, and when we withdraw 100, you are going to get 2 or 3. Okay, thank you very much for today's lesson. You can do practice on your own and play around with this. You can play around with this function, which is tempo and C, and just practice on this, and meet you then. We shall discuss more about this Motoko programming language.